Okay, so hi there, folks. We're now in our next video on college algebra, and we're going to starting with this video, a brand new lesson. Okay, in college algebra, we're done with factorization, and then we're going to start off now with the topic entitled algebraic fractions. So, a rational algebraic fraction, that's the full name of it, is a quotient of two polynomials. Okay, wherein the polynomials are called p of x and q of x. So let's call them that. And we can see that it's in the form of a fraction. Okay, obviously a fraction of this word here. So it's in the form of a fraction wherein one of the polynomials is in the numerator, the other one is in the denominator, where the denominator here, q of x, is never 0. So it just says here that the denominator, q of x, which is found here, is never ever, okay, never ever 0. Okay, so that's the essence of it. So this is a rational algebraic fraction. Okay, we're going to talk about expressions here, not yet equations. And then the denominator must not be equal to 0. So some examples of these are shown here. So as we can see, the numerator here is a polynomial. Specifically, it's a binomial. The other one is also a polynomial, specifically a trinomial. And then we have another example here and over here. So these are, as we can see, they are fractions with algebraic expressions in short. Okay, so that's what we call algebraic fractions. Okay, so our first part of the topic here in this batch of topics in algebraic fractions will be a most important one. It's about the reduction of algebraic fractions. And we're going to have some practice here. Specifically, I have three practice exercises here. So, as we all know, as what was mentioned a while ago, this topic is after factorization. So if you haven't checked out my videos in factorization, you better check them out right now. We will be needing them, okay, here in this videos, and we're going to start with this first one. So we are asked to reduce 9x squared y to the 7th all over 12x cubed y to the 4th. Okay, so we're asked to reduce that in lowest terms. Let's extend the fraction bar. Okay, so how do we do that? Maybe we can rewrite it again. So we have 9x squared y raised to 7th all over 12x cubed y raised to 4. So if you want, we can, um, factorize the numerator and the denominator if you want it to be the thorough way. So we know that 9, prime factorize it, it's 3 times 3. And x squared is x times x. Okay, so this is the long version to make you understand what is happening. Y raised to 7 is, well, y times y times y times y times y. We have 5, 6, 7. So that's y raised to 7. And then we have 12. The prime factorization of 12 is 4 times 2. That's 2 times 2 times 3. X cubed is x times x times x. And y to the 4th is, oops, y times y times y times y. So again, this is a tedious method because this is the long method. I'm going to show you specifically how to do this. How do we do it technically? So we have, as we can see, there are common things here in the coefficients first. I think we can cancel them out, the 3's. So we will cancel out the 3's. The x's, as much as we can, we will cancel them. There are x's, there's here, there's x's here. We cannot cancel this because it doesn't have any pair above. In the y's, we can cancel also. Let's start here. 1, 2, 3, 4. And the answer is pretty much whatever is the leftover after all those cancellations. So what is the leftover anyways? So let's write it down. We have 3 in the numerator, 3. What is left in the numerator is the y 3 times, or rather y multiplied, I mean y, okay, square y cubed, okay, y times y multiplied to itself 3 times. So we're going to write y cubed. So 3y cubed is in the numerator. How about in the denominator? So we have 2 times 2. 2 times 2 is, we know, as 4. X, there's an x, and there's no y left. So pretty much this is our answer for number 1. Okay, so this is the very thorough way. If we're going to make use of the laws of exponent, let's give it one other try. If you want 9 divided by 3, um, let me write it again. X squared y to the 7th all over 12 x cubed y to the 4th. Applying the laws of exponents and the common factor here. What's the common factor of 9 and 12? So it's going to be 3. We're going to divide this by 3 since that's the common factor. Okay, and then we have 9 divided by 3. Oops, sorry. Um, this is not very good to see technically. Um, it should be 9 divided by 3. I write it in a way that 3 divides 3 divided by 9. So how do I write this? Um, 9 divided by 3. Let's put it right here. And 12 divided by 3. Okay, that's pretty much better. Okay, 9 divided by 3 is 3. 12 divided by 3 is 4. We can see here that we have x um, 2 minus 3, and we have y 7 minus 4. So this is equal to 3 over 4. X raised to 2 minus 3 is x raised to minus 1, and then y raised to 3. And then since we have a negative exponent, we'll put that in the denominator. The one with the non-negative exponent, we'll put that in the numerator. So we have 3y cubed 4x. And pretty much that's the same with our above answer. Okay? Now, I think that's pretty much okay with the number 1. Let's proceed to the number 2 now. So number 2, reduce x squared minus x minus 6 to all over x squared plus 4x plus 4 to the lowest terms. So I think you know what we'll do here. We need to factorize it first. And I think it's obvious that they are quadratic trinomials. And we need to find some factors. What are the factors of x squared minus x minus 6? So what are the two numbers that is, if we're going to multiply them, the two numbers, I mean, it will give us 6. And if we're going to add them, combine them, it's going to give us minus 1. So what are those two numbers? So try to think and pause for a while if you need time to answer it. Okay, and then with much enlightenment or thinking, you'll know that there's an x here, there's an x here, and since it's negative, so we know that they have different signs. And since a negative sign here in the middle term, we know that the one with the higher absolute value, the big number, must be negative. So what are the factors of 6? So we have 1 times 6 and 3 times 2. That's pretty much it. So we cannot use 6 times 1 since adding or subtracting 6 and 1 will never give us 1. So it's going to be 3 and 2. So we have minus 3 plus 2. Try to check it out. That's the correct answer. And we have here x squared plus 4x plus 4. And this is pretty much a perfect square trinomial. So we have x plus 2 and then x plus 2. And this is where you will see the essence of factorization in our previous lessons. Why do we need to factor? Because things like this happen. Okay, things like this happen. We can cancel out common terms. As we can see, we have an x plus 2 here in the numerator, and we have 2x plus 2's in the denominator. So pretty much we can cancel them out because they will become 1. Okay? Why does that happen? So if you can imagine, we have 3 over 3 is equal to 1, right? Which is x over x is equal to 1, right? 2 plus y all over 2 plus y is equal to 1. So meaning x plus 2 all over x plus 2 is also equal to 1. So therefore, it is cancelled. It will become 1. And by the identity property of multiplication, anything multiplied by 1 will still be the number itself. So it's like we are hiding the 1 there. So with this method, I hope I explained that well. So we have x minus 3 all over x plus 2. And that's our answer for number 2. Okay, that's our answer for number 2. And then let's go to our last item. This item will be our challenge part here in this video. So in this number, we need to simplify. Okay, we are asked to simplify 3y cubed plus 3y squared minus 2y minus 2 all over 3y cubed minus 3y squared minus 2y plus 2. So what are we going to do here first? These are cubes, okay, and we cannot apply any factor here, any factorization method rather than factoring by grouping. So if we'll follow factoring by grouping, we can see here in the first two terms in the numerator, and I think that follows also in the denominator, they have the same coefficient. So if you haven't saw that yet, so better see it now. I think it's clear to see that we have 3 and 3 here, we have 2 and 2, we have 3 and 3 here, we have 2 and 2. So we want to get those common factors out. And also, um, yeah, we can get those two out. And also, in here, in the first two parts, maybe we can get the common, which is y squared, leaving y here in this term. Okay, so if we'll do that, what do we have? We're going to get the 3y squared in the first pair here, leaving this number to be only y, and leaving this number to be 1 plus 1. Okay, and then we're going to get the common factor here, which is minus 2, and then leaving y over here and leaving plus 1 here. Why does it become plus 1? Because minus 2 times, if we're going to if we're going to distribute this by distributive property, it will give us minus 2y minus 2. Okay, that's the reason, so that's why it's plus. Because the 2 or the negative sign is taken with the factorization. Okay, it's taken with the factor, with the common factor minus 2. Let's do that also in the denominator. So what we have is 3y squared. Then what we have is, if we're going to get this one, so this one will be, the y will be the one which is left, and then minus 1. And then in the denominator, we're going to get, we can get the minus 1, minus 2 rather. And then this will become y. And this one, notice this is plus. So multiplication of integers, numbers, since we got the minus, so this will become minus 2, because minus 2 times minus 2 is going to give us, rather, minus 1 rather, sorry, minus 1, because minus 2 times minus 1 is going to give us positive 2. And with this, we can see from both the numerator and the denominator that this one is common in both of them. Y plus 1, y plus 1, y minus 1, y minus 1. So we want to get that out by factoring by grouping. So we need more space. Let's put it here. And then what we have, let's get the common factor, which is y plus 1 in the numerator. We have it there. And what is left, if we're going to get this, imagine we have 3y squared minus, okay, minus 2. And in the denominator, the same is true. We're going to get the y minus 1. Imagine this, what is left? We have 3y squared. Imagine this, we will cancel this out. We have minus 2. And furthermore, voila! I think this y squared minus 2 can be cancelled out. Okay? It can be cancelled out. So since it can be cancelled out, so what is left with our equation, or with our expression on the right hand side? So what is left is actually y plus 1 all over y minus 1. Because the other factor, this one over here, became 1. And by identity property of multiplication, anything multiplied by 1 will be, or will still be, the number itself. Okay, so that's our first video for algebraic fractions. Surely I'll be making more. The next one will be about the least common multiple, and then the rest. Okay, so I hope you learned something from here. Thank you very much for watching, and I hope you would like and subscribe. Okay, thank you very much.